Hello everybody and welcome back to another brainstorm. So today we're going to be talking about electrolysis in preparation for your GCSE chemistry exam. We're going to split this video up into three main parts. First of all, we're going to cover what is electrolysis, so a basic introduction to it. Then we're going to talk about the electrolysis of molten compounds and then the electrolysis of aqueous solutions. So let's get into it. Okie dokie, so we're going to start off by looking at what exactly is electrolysis, and then we'll start looking at the apparatus used for it and how the different components actually work. So what you'll see in this box here is our standard definition for electrolysis, and I very much recommend that you just learn this for the exam. So electrolysis is basically the breakdown of an ionic compound into its constituent elements, so basically the things that it's made out of. And the most important part is that we do this using an electric current, okay? So we pass an electric current through the compound and it breaks up into what it's originally made up of. So just looking at the apparatus for electrolysis now, is first thing you notice is we have an electrical cell, which supplies us with electrons that we use to make the current. And you'll notice that we have these conducting rods here, which we dip into the actual compound. These two conducting rods are called our electrodes, key term to learn there. And another fact is that they have to be made out of inert or unreactive substances. Example of this is they might be made out of graphite, for example. And the reason for this is just so they do not react with the compound that we're trying to break down, because that's really not what we're looking for. And in terms of these electrodes, a very important mnemonic to learn for your exam is PANK. We have two electrodes in the electrolysis apparatus. We have a positively charged electrode here, and we have a negatively charged electrode here. The positively charged electrode is known as the anode, Pa, and the negatively charged electrode is known as our cathode, Nc, PANK, together. The reason that our positively charged electrode is positively charged because all of the electrons move towards the cell in this direction there. And the reason that our negatively charged electrode is negatively charged is because it's got lots of electrons at it from the cell. And that's important to remember when we talk about what happens to the ions. So the ionic compound that we're actually breaking down is known as the electrolyte, another key term there. And you remember for an ionic compound, it's just full of plus charged ions and negatively charged ions as well. That'll be important in a second. Another key fact to note is that our electrolyte, the ionic compound that makes up the electrolyte, has to either be molten, so we have to supply enough heat energy to melt it to a liquid state, or it can be aqueous, we can dissolve it in water. And the reason for this is these ions that we're talking about in the ionic compound, they have to be able to move to the various electrodes, and we'll talk about what happens there in a second. There's two ways that we can allow them to move or become mobile, is we can supply enough energy to break them free of that ionic lattice that we know that they sit in for ionic compounds. So it can be molten and then they're mobile and able to move, or we can dissolve them in water, by which water molecules actually come in and they break these ions free from the lattice so they can move to the different electrodes. So other than that, we've got the apparatus there, you've got your key definition for electrolysis here, and now we'll actually look at what happens to the ions when we do electrolysis. Okay, so now we've got a basic introduction to what exactly electrolysis is. We can delve a bit deeper by looking at molten compounds. So what happens when we heat up our ionic compound to such a high temperature and then pass the electric currents through it. So we've got the basic apparatus here, which you're familiar with already. And our electrolyte, you remember that is the compound we're trying to break down, is now this time a molten ionic compound. So we'll just take a quick look at what we mean by that. So remember, a molten ionic compound has got positively charged ions and negatively charged ions. What you might find useful is these positively charged ions are called cations, and the negatively charged ions are called anions. That becomes a lot more useful in a second. But basically that's what it is. There's no other ions there except for the ions that make up the compound. So the main fact that you need to remember is that opposite charges attract. You'll know that from your physics, and you know it just generally as well. So a positive is attracted to a negative and a negative is attracted to a positive. So what's going to happen is our positively charged cation is going to be attracted to the negatively charged cathode. That's a very important fact to know. What's going to happen to that cation is, first of all, we've got to ask, why is it a cation? Because it's originally lost electrons and it's become positively charged. So remember, the cathode is only negative, you've got loads of electrons just waiting there on the electrode. So the positively charged cation moves towards the cathode and it gains electrons to become the original atom. What you'll know from before is the acronym oil rig. So oxidation is the loss of electrons and reduction is the gain. So because our cation has moved to the cathode and has gained electrons, we can say that it has become reduced and become the normal element that it was originally. So then we can do the opposite for the anion. It's got a negative charge because remember it's gained loads of electrons previously. So because it's negative, it's going to move to the positive anode, which doesn't have many electrons on it. And when it goes there, it's going to get rid of all of these negative electrons to become neutral again as the original atom. And remember, the loss of electrons is called oxidation. So it has become oxidized. So we can look at a more specific example. So we're going to look at the electrolysis of molten zinc chloride, okay? So whenever you get a question about ionic compounds, the first thing that you want to do is write out the formula, which we've got here. Sometimes you'll get given that in the question as well. And you need to suss out which ions are present in the electrolyte, okay? So first thing we know is it's molten. Shown by the state symbol, you always need to look out with these and make sure that it's not talking about aqueous. So for zinc chloride, we've got the Zn2 plus cation, and we also have the Cl minus chloride anion, okay? So if we apply that to what we know before, what's going to happen is our Zn2 plus is going to move to the negatively charged cathode, because remember opposite charges attract. There, what's going to happen is because it's a 2 plus ion, it needs to gain 2 electrons, so it becomes twice as negative. So it gains 2 electrons, and we can say that zinc has become reduced. And what we'll see in real life is a buildup of zinc metal on that electrode. Oppositely, for the chloride ion, what's going to happen is it's going to move to the positively charged anode, and it's got 1 electron, so it has to lose that 1 electron to become normal chlorine. So it loses 1 electron, we say that chlorine has become oxidized, and it's given off. The scientific name for giving off an element in this scenario is we say that the element has been discharged. So in the first example, zinc has been discharged and chlorine gas has been discharged. Okay, and final thing for these ionic compounds, you need to know how to write a half equation. Now half equations are a little bit difficult, but basically you just need to keep in mind that these tell us where do our electrons go. So we'll start off with the anode, and remember that was the oxidation of chlorine up here. So for the half equation, we need to say that we start off with chlorine ions. What happens is it becomes chlorine, just chlorine gas. And bear in mind that I've written a little 2 here because remember chlorine is a diatomic molecule. So these atoms exist in pairs, and that's very, very important. And obviously an electron is given off as well. Now, final thing I'll mention is look at the balancing that I've done here. So originally, if we didn't have those there, which is what our normal equation would say, so we've got a diatomic chlorine that's made. To make 2 chlorines, we have to have 2 chlorine ions as well. And if each one of those chlorine ions gives off 1 electron each, we say 2 electrons are given off. Conversely, at the cathode as well, remember we had the reduction of zinc. So we're going to start off with our Zn2+. What's going to happen is, remember, because we've got the 2 plus charge, it needs to gain 2 electrons as well. And when it gains those 2 electrons, it just becomes zinc, and zinc isn't diatomic or anything. So those are the molten ionic compounds, and now we'll look at the aqueous ones. Alright, so we've taken a look at molten compounds, and we're going to finish off by looking at aqueous solutions, okay? So in this case, our electrolyte is going to be an aqueous ionic compound, and remember, we said that aqueous means that it has been dissolved in water. So because it's dissolved in water, we also have the ions in water that we have to worry about as well. So the main thing to remember here is that water is made up of hydrogen cations, and we also have our hydroxide anions. So when water is present, these two we always have to take into consideration. And here's the equation for that. Water can dissociate into these 2 ions. So we have a couple of rules that we just need to memorize. If you memorize these, you'll be completely fine. So what happens is, because we've got these ions, and bear in mind we also have the positively charged ion and the negatively charged ion from the original ionic compound that has been dissolved, we sort of have a competition at each one of the electrodes to see which one is going to be discharged. So at the anode, which you'll remember is positively charged, we're going to have a competition of negatively charged ions because those are what attracted there. So usually it's a competition between the negatively charged hydroxide anion, which comes from the water that it's dissolved in, or whichever negative ion is present in the original ionic compound. So we don't know what that is. The rules for this are, if the electrolyte has any halide ions, so remember halide ions are going to be Br minus, Cl minus, I minus, or F minus. It's the halogen that is always discharged. If it's anything else other than a halide, then OH is discharged, and when our hydroxide anion is discharged, it's discharged as oxygen gas. So if we take sodium chloride as an example, if that was aqueous, we've basically got a toss-up between the Cl- ion or the OH- ion from the water. So because we've got the halide here, chlorine is always going to be discharged as the gas. So at the cathode, you remember we said that the cathode is negatively charged, so we've got a toss-up between positively charged ions that move towards it. So what's going to be discharged? Well, it's either going to be the H+ from the water, or whichever positively charged ion is present in the original compound. The way that we decide which one is discharged is basically we ask ourselves which one is least reactive. That's the one that's discharged. So if we use the same example, if we've got NaCl, so our salt, it's a toss-up. Either it's going to be the H+ that's discharged, or we've got the sodium that's discharged. But we already know that sodium is a very reactive metal, especially on the reactivity series. So hydrogen is going to be discharged as hydrogen gas. Okay, so using that information, we can look at a specific example. We're going to look at the electrolysis of brine. So brine, you might know from your tuna cans, etc. It's an aqueous solution of sodium chloride. So basically it's just salt dissolved in water. So again, just like we did with the molten compounds, we need to look at what ions are we dealing with, what ions are present. First thing we'll look for is the state symbol. We know it's aqueous, so we know that the salt is dissolved in water. Because it's sodium chloride, we'll know that we've got the sodium cation. We also have the chloride anion. And remember, because it's dissolved in water, we also have these from the water. We have the hydrogen cation, and we also have a hydroxide anion. So when we're looking at the electrodes, we're going to have a competition between these two. I'm going to have a competition between these plus charged ones as well. So let's look at that competition then. At the anode, what's going to happen is we're either going to have chlorine is discharged or the hydroxide is discharged. And remember from our rules that if a halide ion is present, the chlorine is always going to be discharged. So it's chlorine. Then we can look at our half equation. What actually happens to that chlorine? Well, we've seen this half equation before. So chlorine ions become diatomic chlorine, and because of that we need 2 chloride ions, and each one of those releases 1 electron, so 2 electrons are released. Now at the cathode we have a toss-up between hydrogen or sodium. Well, we know sodium is a lot more reactive than hydrogen, so it's hydrogen that is going to be discharged as a gas. So for our hydrogen, we have 1 hydrogen cation, which gains 1 electron, but it becomes H2 because, again, just like chlorine, hydrogen exists diatomically. So because of that, we need to balance this up, okay? So because it's diatomic, we end up with 2 hydrogen molecules. We need 2 hydrogen ions to make that up, and each one of them has to gain 1 electron each, so we need 2 electrons to make that up. Now, what we have left is, in the electrolyte, we have the hydroxide anions and we have the sodium cations. Now, only for the GCSE course you need to know about brine. What happens with these 2 leftover ions, if you will, the ones that are not discharged, they combine to form sodium hydroxide. And one of the common uses of this compound is in bleach. You might be asked about that as well. Finally, the only half equation which we haven't seen in this video is if the hydroxide anion is discharged, what is the half equation? Now, this is a very, very nasty half equation. So I think the easiest thing for you guys to do is just learn this off by heart. So for OH- ions, they become 1 O2, diatomic molecule again. They release 2 water, and they also release 4 electrons. Easiest thing to do with that is just learn it, learn the numbers, and you'll be completely fine. And with that, I'd just like to say thank you guys all for watching. If you did enjoy the video, please make sure to hit like and subscribe, and I'll see you guys soon.